Hello, and welcome to Team Thermos's final video update. Below, you will find the QR codes to our MATLAB function demo, our hardware demo, and our DWSim demo. Please go check them out because there's a lot of work there that we are highly proud of. Today, we have Mr. Tom Potts, who is our infamous mentor that is going to do our roundtable discussion with us today.
So when you were taking your data off of your different systems, your asphalt versus your evacuated tubes, what correlation did you have between that data and the model that you ran to emulate that system?
We didn't actually have a mathematical model that we were judging our simulation off of. We compared our asphalt design against the commercially available one to see which one could heat up faster, or if they were comparable when we ran water through them, if they heat up in about the same amount of time, or to what temperatures they could reach. And they were pretty comparable. In fact, the asphalt one, because of maybe its surface area, outperformed the commercially available one.
What was the primary method you used to control the pump?
We created a low side pump driver. We designed this schematic for it. And what we were able to do is use a Raspberry Pi with Python coding and implemented the PWM, or pulse width modulation, on one of the pins. We had a minimum duty cycle of 30 up to duty cycle of full.
So do you have an idea of what that flow rate was at the optimal heat transfer rate into your water?
We found that roughly 7 milliliters per second through the actual the asphalt itself gave us a significant amount of heat added to the water.
Appeared to be a ground loop problem in the system. Can you give a little insight on how that was corrected or how that came about?
Well, when we were looking at the testing at the input of the gate, we seen that it had an oscillation. We actually used the 12-volt power supply we were using for the rest of the system to make sure the ground systems were all connected, so we weren't getting that feedback loop.
So guys, what are your plans or ideas about moving this forward into more of a commercial environment?
Well, I think there's a lot more we need to do, especially with people of other fields. So we definitely need other people who know fluids. It'd be great to have assistance from somebody who is very, very knowledgeable with like an organic Rankine cycle and the Kalina cycle.
You know, the biggest thing for the simulation side would just be getting a simulation that would work with the transient state, the startup, and the black body itself, to see more realistically how much power could be generated, what trigger points would start it, and when it would start the cycle off.
I would like to say thank you, team, and thank you, Tom, and I hope everybody got to learn a little bit about our team as we went through this and some of our difficulties.
Bye.
Bye.